According to the National Electrical Code, often abbreviated as NEC, all electrical installations in an existing building must comply with the current NEC requirements. This applies regardless of the percentage of new work being performed. Tapping into existing wiring is generally not permitted unless the existing wiring adheres to the current NEC requirements. This encompasses several crucial factors. Firstly, wire size and type must be compliant. Secondly, appropriate circuit protection must be in place. Thirdly, proper grounding and bonding are essential. Fourthly, arc fault circuit interrupters, or size, must be installed where required. Fifthly, ground fault circuit interrupters, or GFCIs, are necessary in applicable locations. If the existing wiring fails to meet these current NEC requirements, a complete replacement with all new electrical wiring becomes necessary. This includes the installation of new electrical panels, wiring for both power and grounding outlets, switches, and lighting fixtures. However, there are limited exceptions to the general rule of requiring all new electrical wiring in an existing building. These exceptions primarily involve minor modifications and historic buildings. Small changes to existing circuits, such as the addition of a few outlets or switches, may be permitted, provided the existing circuit is not overloaded and continues to meet the current NEC requirements. Electrical installations within designated historic buildings may be granted exemptions from specific NEC requirements to preserve the building's historical character. As a best practice, it is highly recommended to engage a licensed electrician to conduct a thorough inspection of the existing wiring. This inspection will determine whether the wiring meets the current NEC requirements. If compliance is confirmed, tapping into the existing wiring may be a viable option. However, in the majority of situations, opting for a complete replacement with all new electrical wiring is the safer and more reliable approach. This ensures full compliance with the NEC and mitigates potential risks associated with outdated or non-compliant wiring. The NEC is a comprehensive set of standards designed to safeguard people and property from electrical hazards. It is regularly updated to incorporate new technologies and address emerging safety concerns. Therefore, staying informed about the latest NEC requirements is crucial for anyone involved in electrical work, whether it is a homeowner undertaking a small renovation or a licensed electrician performing a major installation. Understanding the NEC involves familiarity with its various articles and sections, each addressing specific aspects of electrical systems. For example, Article 210 covers branch circuit, outlining the requirements for conductor sizing, overcurrent protection, and outlet placement. Article 250 deals with grounding and bonding, emphasizing the importance of creating a low impedance path for fault currents to return to the source, thereby minimizing the risk of electric shock. Article 300 provides general wiring methods, specifying the acceptable ways to install conductors and cables in different environments. Article 400 covers flexible cords and cables, outlining their permitted uses and limitations. Article 500 addresses hazardous locations, such as areas where flammable gases or combustible dusts are present, requiring special equipment and installation methods to prevent explosions or fires. Article 600 deals with electric signs and outline lighting, specifying the requirements for their construction, installation, and maintenance. Article 700 covers emergency systems, ensuring that essential electrical services such as lighting and fire alarms remain operational during power outages. SIs and GFCIs are critical safety devices that protect against electrical shock and fire. SIs detect arc faults, which are unintentional electrical discharges that can ignite flammable materials. GFCIs detect ground faults, which occur when current leaks to ground through an unintended path, such as a person's body. Both SIs and GFCIs critically interrupt the flow of electricity, preventing serious injury or damage. Wire size and type are essential considerations in electrical installations. The size of a wire determines its ampacity, or the amount of current it can safely carry. Using undersized wires can lead to overheating, insulation damage, and even fires. The type of wire insulation must be appropriate for the environment in which it is installed. For example, Some types of insulation are resistant to moisture, heat, or chemicals. Grounding and bonding are crucial for creating a safe electrical system. Grounding provides a path for fault currents to return to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault currents and minimizing the risk of electric shock. When evaluating existing wiring, it is important to consider its age, condition, and compliance with current NEC requirements. Older wiring may have deteriorated insulation, loose connections, or other problems that can create safety hazards. Even if the wiring was compliant with the NEC at the time of installation, it may not meet the current requirements due to code updates. A licensed electrician can perform a thorough inspection of the existing wiring, identifying any potential problems and recommending appropriate solutions. When planning an electrical renovation, it is essential to obtain the necessary permits from the local building department. Permits ensure that the work is performed in accordance with the NEC and other applicable codes. The building department will typically inspect the work at various stages to verify compliance. Working without permits can result in fines, delays, and potential safety hazards. In addition to the NEC, there may be other applicable codes and standards that must be followed. For example, local building codes may have additional requirements for electrical installations. The Americans with Disabilities Act, or ADA, has requirements for the accessibility of electrical outlets and switches. Energy codes may have requirements for the energy efficiency of lighting fixtures and appliances. Staying informed about all applicable codes and standards is essential for ensuring a safe and compliant electrical installation. When selecting an electrician, it is important to choose a licensed and insured professional with experience in residential electrical work. A licensed electrician has met the requirements of the state or local licensing board, demonstrating their knowledge and skills in electrical installations. Insurance protects you from liability in case of accidents or damage during the work. Ask for references and check online reviews to get an idea of the electrician's reputation and quality of work. A qualified electrician can help you plan your electrical renovation, select the appropriate materials and equipment, and ensure that the work is performed safely and in accordance with all applicable codes and standards. Remember, electricity is a powerful force that can be dangerous if not handled properly. Working with electricity requires knowledge, skill, and attention to detail. If you are not comfortable performing electrical work yourself, it is always best to hire a licensed electrician. Ensuring electrical safety is not merely a matter of code compliance but a commitment to protecting yourself, your family, and your property from the potentially devastating consequences of electrical hazards. Understanding the fundamental principles of electricity and adhering to established safety practices are paramount for anyone undertaking electrical work, regardless of the scale or complexity of the project. Before commencing any electrical task, it is imperative to disconnect the power supply to the circuit you will be working on. This can be achieved by turning off the corresponding circuit breaker or removing the fuse at the electrical panel. To ensure that the circuit is indeed energized, use a reliable voltage tester to verify the absence of voltage at the wires or devices you will be handling. Never assume that a circuit is dead without first confirming it with a tester. When working with electrical wires, always use insulated tools specifically designed for electrical work. These tools provide a layer of protection against electric shock. Avoid using tools with damaged or worn insulation, as they can compromise your safety. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves, to protect your eyes and hands from potential hazards. Safety glasses shield your eyes from flying debris, while gloves provide insulation and protect your hands from cuts and abrasions. When making electrical connections, ensure that the wires are properly sized for the circuit. Using undersized wires can lead to overheating and potentially cause a fire. Consult the NEC or a qualified electrician to determine the appropriate wire size for the circuit's ampacity and length. Make sure that all electrical connections are tight and secure. Loose connections can cause arcing, which can generate heat and potentially ignite flammable materials. Use the correct type of connectors for the wires you are joining and ensure that they are properly installed. When working with electrical outlets and switches, follow the manufacturer's instructions carefully. Incorrect wiring can create a safety hazard. If you are unsure about how to wire an outlet or switch, consult a qualified electrician. Never overload electrical circuits. Overloading can cause the circuit breaker to trip, but it can also overheat the wires and potentially start a fire. Avoid plugging too many appliances into a single circuit, and be aware of the total amperage draw of the devices you are using. Keep electrical cords and wires away from heat sources, sharp objects, and moisture. Heat can damage the insulation on cords and wires, while sharp objects can cut through the insulation, exposing the bare conductors. Moisture can create a path for electricity to flow, increasing the risk of electric shock. Inspect electrical cords and wires regularly for damage. If you find any frayed, cracked, or otherwise damaged cords or wires, replace them immediately. Never attempt to repair damaged cords or wires yourself, as this can be dangerous. Be aware of the location of underground electrical cables before digging. Contact your local utility company to have them mark the location of underground cables before you start digging. Digging into an underground electrical cable can cause a serious electric shock and disrupt electrical service to your neighborhood. If you are working on an electrical project that involves working at heights, use a ladder that is in good condition and properly positioned. Make sure the ladder is stable and level before climbing it. Avoid using metal ladders when working near electrical equipment, as they can conduct electricity. If you are unsure about any aspect of electrical safety, consult a qualified electrician. An electrician can provide you with valuable advice and guidance on how to perform electrical work safely. By following these electrical safety tips, you can minimize the risk of electric shock, fire, and other electrical hazards. Remember, electrical safety is a shared responsibility, and it is important to take precautions to protect yourself and others from harm. The NEC serves as the cornerstone for safe electrical installations. Its comprehensive guidelines, regularly updated to reflect technological advancements and emerging safety concerns, are indispensable for anyone involved in electrical work. From homeowners undertaking minor repairs to licensed electricians managing complex projects, adherence to the NEC is crucial for safeguarding lives and property. Staying informed about the latest NEC revisions is essential, as these updates often incorporate new requirements or clarify existing ones. Familiarizing yourself with the code's structure and content will empower you to make informed decisions and ensure compliance with industry best practices. Beyond code compliance, a commitment to electrical safety encompasses a broader understanding of electrical principles and safe work practices. This includes recognizing potential hazards, using appropriate tools and equipment, and following established procedures for de-energizing circuits and making connections. Cultivating a culture of safety within your home or workplace is paramount. Encourage open communication about electrical concerns, provide training on safe work practices, and regularly inspect electrical systems for potential problems. By prioritizing safety, you can create an environment where electrical hazards are minimized and the risk of accidents is significantly reduced. Remember, electricity is a powerful force that demands respect and caution. By combining a thorough understanding of the NEC with a steadfast commitment to safety, you can ensure that your electrical installations are not only code compliant but also safe for yourself, your family, and your community.